In this video, I am going to explain discharging concept of the capacitor. First one, circuit diagram. In the last video already I have explained how to charge the capacitor and derive that expression Vc of t is equal to instantaneous voltage across the capacitor is equal to source voltage into 1 minus e power minus t by RC. This is the charging voltage across the capacitor Vc of t. Now I will concentrate on discharging concept of the capacitor. Circuit diagram is this is the switch. This is a switch. Switch is S is closed. This one is a resistor R. This one is capacitor C. The voltage across this capacitor is Vc. At steady state condition has been reached. The capacitor is fully charged to source voltage. V is the source voltage. Source voltage. At that instant, here the source voltage acts as a voltage source acts as a short circuit. Voltage source acts as a short circuit. The capacitor is charged to source voltage V shown in figure. The capacitor here acts as a voltage source. The capacitor is discharged through resistor R. The current in the circuit is I. The current in the circuit is I. Apply KVL to that circuit. Apply Kirchhoff voltage law to the above circuit. This is IR plus Vc, voltage across the capacitor Vc is equal to 0. We know that capacitor current I is equal to C into dVc by dt, where Vc is the voltage across the capacitor. This is the first equation. This one is second equation. Substitute second equation. Substitute second equation in first equation. Okay. In place of I, replaced with D C into dVc by dt into R plus Vc is equal to 0. Rearrange the terms. RC dVc by dt is equal to minus Vc. Cross multiplication. RC dVc is equal to minus Vc dt. Rearrange this one. dVc by Vc minus dt by R. Integrate the above equation on both sides. Integrate the above equation on both sides. That is equal to dVc by Vc is equal to minus dt by RC. We know that dVc by Vc is equal to log mod VC minus T by RC plus some constant C. And the discharging capacitor circuit diagram at T is equal to 0, starting from again in the discharging mode, starting from the time period from 0 only, 0 seconds. At that instant, the capacitor is fully charged to V volts. That means VC is equal to V volts. Integrating the T is equal to 0, substitute initial condition. The capacitor is fully charged to source voltage. Substitute T is equal to 0 in the above equation. Log VC by C. Substitute T plus C. Therefore, constant C is equal to log VC by C. This C value is substitute the C value is substituted in this equation. Therefore, log VC E is equal to minus T by RC. C means log VC E. At T is equal to 0, VC is equal to T is equal to 0, VC is equal to V. At T is equal to C, 0. VC is equal to V. VC is equal to V. At T is equal to 0. Therefore, VC is replaced with V. Here, log VC E minus log V base C is equal to minus T by RC log M by N, and that means VC by V base C is equal to minus T by RC. VC by V, VC is the voltage across the capacitor by source voltage into E power minus T by RC. Therefore, VC is equal to V into E power minus T by RC. Where R and C, product of R and C is called as a time constant of the circuit. Time constant. The capacitor is a graph. The capacitor is here time versus VC, instantaneous voltage across the capacitor VC. At T is equal to 0. At T is equal to 0 means substitute VC is equal to V into E power minus T by RC. Substitute at T is equal to 0. VC is equal to V into E power 0. V power 0 means 1. VC is equal to V. VC is equal to source voltage. As time goes on increases, that means the different constants RC, 2RC, 3RC, and so on. That means tau, 2 tau, 3 tau, and so on. The capacitor is discharged through a resistance R. At tau RC, the value of VC is equal to 0.368 P. This is the discharging concept of the capacitor. These concepts are very, very important in GATE examination point of view. Okay, thank you.